Welcome everyone. Hope you guys are enjoying your day at math class so far. And today we're going to explore factoring. We're going to start factoring. And remember, factoring, the word factor means multiplication. So what we're going to do is we're going to rewrite expressions as multiplication. And that's what factoring is. Today we're going to look strictly at greatest common factors. And so, a simpler form, this isn't factoring yet, but it says find the greatest common factor of the following terms. So we have 4, 16, and 8. Remember, factors are things that multiply. So we're basically trying to say, what is the largest number that divides evenly into all these? So 4 can be written as 4 times 1 or 2 times 2. And then we have 16 can be written as 16 times 1, but there's no factor of 16 in this one, so that can't be right. We could also do 4 times 4 or 2 times 8. Well, they so far both have that factor of 4, so that's right now the highest. And then if we look at 8, we can do 1 and 8 or 2 and 4. So they do all have a common factor of 2, but we're looking for the greatest common factor, so that they each have a 4 in them. That has a 4. This has a factor of 4, this has a factor of 4. So the greatest common factor for number 1 is 4, because 4 can divide evenly into all these. 4 divided by 4 is 1, 16 divided by 4 is 4, and 8 divided by 4 is 2. And that is the largest number that divides into all of them. If we look at number 2, now we're talking about variables. So remember, x to the 5th means x times itself 5 times. X squared means x times itself 2 times, and x to the 3rd means x times itself 3 times. So what do they all have? We're not looking at the exponents to divide, we're just looking to see what they all have, at least x times itself. This has x times itself 2 times, this has x times itself 3 times, so it has at least 2 of them, and this has at least x times itself 2 times as well. So here the common factor would be x squared. So when you're talking about variables with exponents on them, you're just ultimately looking at the smallest exponent. The smallest exponent is 2, so x squared would be our greatest common factor. Now if we look at 3, it has both numbers and variables, so kind of think of it as a two-step problem. If I look at my numbers, 100, 25, and 75, what number can I divide 100 by, 25 by, and 75, the largest? And that would be 25. 100 divided by 25 is 4, 25 divided by 25 is 1, and 75 divided by 25 is 3. So I can divide each of those by 25. And if I look at my variables, x to the 1st, x to the 3rd, x squared, they all have at least x to the 1st power. So 25x is the GCF, or is the greatest common factor. Remember, when we say the word factor or factoring, factoring is rewriting the expression as multiplication. So we're going to take an expression that has just terms added or subtracted together, and we're going to write it so there's multiplication in it. And so the first type of factoring we're looking at is the common factor, the greatest common factor, or what we'll say the GCF. And finding the GCF is the reverse of the distributive property. Okay, remember the distributive property was where we had something like 2 times the quantity of x plus 3, and we wrote that as 2 times x, and then 2 times 3 was 6. What we're going to do now is we're going to start with the 2x plus 6 and rewrite it with the number in front. So this is now factored because they're separate by multiplication now. So when you're doing GCFs, you find the largest number and or variable that is in common in all the terms. You are then going to divide, and we'll write this here, divide the GCF by each term. You are always looking to pull out a GCF first. That's always your first step. So here are our steps. I have 25x cubed plus 75x squared. Step 1 says determine the GCF of the expression. Well, I have 25x cubed, 75x squared. The number, 25 goes into 25, and 25 also goes into 75. So the largest number that goes into both is 25. And then this has an x cubed, this has an x squared, so they all have at least x times itself 2 times, or x squared. So my greatest common factor is 25x squared. So the way we do this then is once you know the GCF, you're going to write that GCF in front of parentheses. So 25x squared. Make one set of parentheses, because if you notice, since it's reversed the distributive property, the distributive property only had one set of parentheses. And then what we're going to do is we're going to divide each of our original terms by the GCF. So notice how I divide each of these by 25x squared. And since I had 2 terms to start, I should still have 2 terms in my parentheses. So if I'm doing 25x to the third divided by 25x squared, 25 divided by 25 is 1. X cubed divided by x squared is just x. Then I have a plus sign. 75 divided by 25 is 3. And x squared divided by x squared, those would cancel out. So this is now factored with a GCF. Notice it does look like the reverse of the distributive property where, and guess what? We can always check to make sure we did it correctly by distributing that GCF. So if we just want to double check, if I did 25, I'll rewrite this down here. This is just a check, okay? This isn't just making sure you did it correct. 25x squared times x will be 25x to the third. And then 25x squared times 3 would be 75x squared. And notice that's what we had originally. So this is checked. We did it correctly. This is factored though. This is factored because we're separated by multiplication here. This is your check. All right, let's try some examples here. So 6x squared plus 9x. So the GCF, what number or variable goes into both 6 and 9? So 3. 3 goes into 6 2 times, 3 goes into 9 3 times. And this has x squared, this is x, so they each have at least x to the first. Remember, when you're doing GCFs, you put that GCF in front, one set of parentheses, and then we're going to divide each of my numbers by the GCF. So 6x squared divided by 3x is 2x. And then 9x divided by 3x, those x's cancel, and I'm left with just 3. So this is now factored. Again, it's separated by multiplication. If you want to do a quick check to see if you did it correctly, 3x times 2x is 6x squared. 3x times 3 is 9x. And that's what we started with, so that's checked. All right, go ahead and try number 2. For number 2, the GCF doesn't have any variables in it because this has a y squared. This doesn't have any y's at all, so there's no GCF variable. But the number variable would be a 2. So I have a 2 in front of one set of parentheses. I divide everything by 2. And then I do 14 divided by 2 is 7, and then I have y squared. 18 divided by 2 is 9. And again, if I did a quick check, 2 times 7y squared is 14y squared. 2 times 9 is 18, so it checks. 3 is a little tricky because we got a lot of variables going on. There is no number that goes into both because this has a 2 and this doesn't have any variable or any numbers. But if we look at the number or the variables, this has an x squared, that has an x, so they all have at least an x to the first, and they all have at least a y to the first. So xy is my GCF. Remember, I started out with 2 terms, so I should have 2 terms in the end. And I'm going to divide each of my original terms by xy. So x squared divided by x is just x. y divided by y, that would cancel out. Minus 2 divided by 1 is 2. X divided by x would cancel out. And y squared divided by y is y. Again, quick double check. Y times x would be x squared y, which is what we had. And then xy times negative 2y would be negative 2xy squared. All right, so that is GCFs. I hope you are understanding this. If you don't, please let us know.